Okay, let's try this again. The first time I tried it, something was not good. The second time I'm trying it, I hope something is better. Okay, well, let's just start there at, can people hear my voice? Can you hear me? Can you see the white blank screen in front of you? Can you see the pen that is placed before you? Can you see this pen? Can people confirm that? Yes, you can. Okay. East the beast, I can see it. East the beast can see it. Of course you can. Yes, Steez, you can too. Alright. Yeah, guys, hey, something was happening earlier on. I was like, icon. I don't know what's happening. Something was definitely happening earlier on. Okay. Maybe my people in the, yeah, there we go. Alright, I see people are coming in now because, yeah. Sorry guys, I was struggling with, apparently something was happening because it's either my network, because I was on, I could see people were on, I could see people liking the live, but hey, no one responding. That was the thing, you see. Wow, Uzwe, what a way to start the live session, eh? What a way to start the live session. Uzuzu. Thank you so much for the TikToks. Can I ask the grade? It's grade 11, eh? Momu muhle. What? Momu muhle. Yeah. Hey, people's TikTok names. Yeah. You just know where the danger is. Alright, as we wait for people to come in, any people like what's grade 11? This is grade 11, this is for grade 11, and yes, a grade 12 student can definitely benefit from this grade 11 live session. Why? Because grade 11, guys, is such a sweet predecessor of the grade 12 work, you know. So someone who's here who's probably looking for a grade 12, the land of the living for the grade 12s, if you are here for this grade 11 session, you should also be here because some of the things that I will be discussing here will definitely surface in that level of, yeah. So let us see. I'm kind of feeling a bit open. So if people feel like they have pressing questions around specific topics, I can take those, you know. I'll make this an open session. There is a, what you call, yeah, I think I'm willing to give you grade 11s a chance. Give you guys a chance if you have pressing questions. But there's a particular one, you know, like yeah. So earlier on today, I actually sent a problem in the grade 11 group. I sent 3 of them, and I think I want to do the corrections for those 3 problems because people did attempt it. Some people did very well attempting the problems, but like some of you, you know, it was very, yeah, and I don't know. Yeah, it was very, you know. So, me being open, like I said, this is grade 11, Bobo or Bobo. Is it Bobo or Bobo? Yeah, it's Bobo. Beautiful. Some people's words. Chances are rare. So I'm just for now, I'm gonna obviously like look at a few, like I wanted to look, for instance, at a few questions surrounding the following things, and I'm just gonna go on. All right. So first and foremost, let's look at a question like this. For instance, this is an exponential question, and I just wanna talk to some important particular things that I feel need to be mentioned, you know. So this is a typical simplify question for exponents, and 50 to the power x plus 1 over 2 to the power x plus 1 times 25 to the power x plus 1. So yeah, I'll just sort of like take it one and like, you know, these problems that I posted there, and I just want to address certain things. So this is 50 to the power x plus 1, and then there's 2 to the power x plus 1 times 25 to the power x plus 1. This here, if you look at what is present, we have a line which stands for divide. We have 50, it's isolated at the top. You have 2 to the power x plus 1, which is multiplied to 25 to the power x plus 1. So there's like a suggested sort of approach, because when you have multiply and divide in your exponential expression, okay, and it's clear that your bases are numbers, all right, then it stands then to reason that you need to look at those base numbers 50, 2, and 25, and you need to look at them and be like, okay, if those are composite base numbers. Now this word composite, if you remember in grade 8 and 9, you learned about composite numbers. Composite numbers are numbers that have more than 2 factors. Okay, so it's a matter of converting these composite base numbers to prime base numbers. So you need to move from composite to prime. All right. And in earlier grades, in grade 8 and 9, I don't know if you guys remember that thing that they refer to as the ladder method. All right. But you see, the thing is, we don't want to complicate our lives and have to use the ladder method and put 50 there and then try and find all the prime numbers that go into 50. We used to do that in earlier grades to sort of like help facilitate this development of expressing 50 as a product of its prime factors. We don't have to do that anymore. We have trusted calculator that can do that for us, right? So all we do is we go to our calculator, all right, and we first obviously switch it on, and when it's on, we just make sure that all the relevant options that basically will allow us to have the answer expressed in numerical values are there. We have M, we have D, all right, and then we have MATH for math. So all composite numbers, if we want to change them to prime base numbers, we're simply going to take that number, press equal, press shift, and then we will press fact, F-A-C-T. So let's experiment on this. You have a 50 that you want to check out as a product of its prime factors. So 50, you press equal, you press shift, you press, there it is, F-A-C-T. By pressing shift, that allows us to access all these yellow thingamabobs. Do you see these yellow thingamabobs? We can access them. And what do you see? 50 is expressed as 2 times 5 to the power 2. Okay, no problem, Sapak. So 2 times 5 to the power 2. So in the place of 50, we write 2 times 5 to the power 2 in brackets, right? Because that is a representation of 50, the composite base number, expressed as a product of its prime base numbers. What did we do to do that? We simply pressed the number, we pressed equal, we pressed shift, we pressed fact, and then we got 2 times 5 to the power 2 in the place of 50. Then that x plus 1, we write it still as that exponent that was initially there, but having converted our 50 to a product of its prime factors. 2 is a prime number and 5 is a prime number. These are prime bases. And 5 to the power 2 is 25. You times that by 2, you get that 50 back. Okay, so we need to always where there's multiplication and division between numerical bases. We need to always look at the numerical bases and ask ourselves, are the numerical bases composite numbers? Because if they are, we need to be on the mission of converting composite base numbers to prime base numbers. And I suggested that you write in your calculator, you punch into your calculator that number that is a composite number. You press equal, you press shift, you press fact, and then in brackets, please, you substitute your composite number for your prime base. And there it is, 2 times 5 to the power 2. In brackets, I have that x plus 1 outside. Let's go into the denominator. There's 2 to the power x plus 1. This base here, 2, is already a prime base. So once again, to the beautiful daughter of God who's asking there, what is a composite number? The number 50 is what we refer to as a composite number. Why do we call 50 a composite number? It's because 50 is a number that has more than 2 factors. So composite numbers are simply numbers that have more than 2 factors. In other words, these numbers, they are divisible by more than 2 numbers. 1 goes into 50, that's 1 factor. 2 goes into 50, that's another factor. 5 goes into 50, that's another factor. So you see all these numbers, they actually go into 50, and there's more than 2 of them that go into 50. So our mission is to convert our composite base numbers to prime base numbers. Now, what is a prime number? A prime number, on the other hand, is a number that has only 2 factors, and those factors are usually 1 and itself. So for instance, if you're thinking about prime numbers, 2 is a prime number. Why? Because it has 2 factors. What are the factors of 2? It's 1 and 2. 5 is a prime number. What are the factors of 5? 1 and 5. That's why we say that a prime number is a number that has only 2 factors, 1 and itself. So I hope you understand this idea of the first step. Whenever we have division and multiplication only in a exponential expression, and there are numerical bases, meaning there are number bases. There's 50, which is a base here on the top. It's alone. It's got division, the division line. Underneath we have 2, which is another number base, to the power x plus 1, which is an exponent, times, this dot means times what? Times 25, which is another number base, which is composite, raised to the power x plus 1. That means in order to simplify this, we need to first convert these composite base numbers to prime base numbers. And I suggested a method, and that is, if we want to convert these composite numbers to prime base, all we do is you take your composite number, you punch it into your calculator, 50, you press equal, I've pressed equal, you press shift. Why do we press shift? Because shift allows us to access all these yellow things in our calculator. So we press shift, we press fact, because we want the factors, and more specifically the prime factors of 50. There we have them, 2 times 5 squared. You go and substitute in the place of 50 that 2 times 5 squared, which represents 50. 2 and 5 are prime bases, and you still raise it to the power x plus 1, having put this in brackets. Okay. Then we proceed. We go down to the denominator. We have 2. 2 is already a prime base, so it is sorted. Times 25. This is not a prime base, it is a composite base. Why? Because it has more than 2 factors. So we want to convert this 25 into a what? A prime base number. So we do the same thing. Go to your beautiful calculator. You punch in 25. There it is. You go and press equal. There you go. You go and press shift. There it is. And then you go and press fact. Do you see what happens? 25 is now expressed as 5 squared. You put it in brackets and you write to the power x plus 1 on the outside. That is step number 1 of simplifying a exponential expression that has only, and I repeat, it has only multiplication. As you can see, 2 is multiplied to 25 to the power x plus 1. 2 to the power x plus is multiplied to the power 25 to the power x plus 1. And what? Division, guys. Division meaning the line that stands for divide. Here there's no addition and there's no subtraction. So where there's division and multiplication alone, we can always be assured of converting composite base numbers to prime base numbers by utilizing this calculator method. That's step 1. Step number 2, and please listen to me carefully. Step number 2, you then have to apply, especially with those composite bases that you converted, we apply law number 3 of exponents. Maybe you're going to ask, what does law number 3 of exponents say? It says whenever you have a base raised to a certain exponent and it's raised to another base, what do? You multiply the exponents. Whenever you have a base raised to a certain exponent and external to that particular base, base, you have another exponent. You multiply the exponents. I think it even went on to talk about another law which basically springs forth from the other one, and that is if you have two bases multiplied to each other, okay, and they are raised to exponents, then there's an exponent on the outside. All you do is you distribute a to the power n times p. That's for a is sorted. B to the power m times p, to sort out the multiplication where the base is raised to the power m as well. So it's like A is hungry. He needs to have a meal on the outside. So basically he goes, grabs the meal and he multiplies what he's got. B as well, an independent entity from A, because the relationship between A and B is multiply, and this is very important. The relationship is multiply between A and B, right? You can then freely distribute n and p by multiplying, and for the base b you can multiply m and p, and that's why basically you have a to the power n times p times b to the power m times the p. So it's like we're distributing the exponent, and that's very important. Brackets mean multiply in this case, all right? This also stands true when the relationship between the bases is actually one of division and there's an external exponent on the outside. You can freely go ahead and say a to the power m times p. And then in like fashion, because b is raised to the power n, you say b to the power n times p. Okay, the relationship between a and b in this case is divide. So that allows us to then distribute the exponent by multiplying the exponent that is on the outside. These are so fundamental and basic, and they are so crucial because once we know these basic laws, it allows us to be able to freely simplify, you know. Also, take note of the following, which is very wrong, and that is if you have a to the power m, and let's say this time round they are separated by a addition sign, and let's say it's raised to the power p. if there's a plus, guys, or if there's a minus, we cannot do the following. Please, guys, take note. We cannot do the following. You cannot, if A and B are separated, they are separate terms, and they have an exponent on the outside, you cannot say A to the power m times B plus B to the power n times B. This is absolutely unacceptable. This only works and applies when the bases have a relationship, and I repeat, of what? Of multiply and divide. This law works. But if the relationship between different bases is one of addition and subtraction, we cannot distribute by multiplication the exponent. It is wrong. It is not allowed. And that is a fundamental rule in exponents. And how many times, and I'm sure you guys, maybe if I can just give you a practical example of this. If you have a plus b, the whole thing squared, do you say that the answer is a squared plus b squared? Is this correct? And maybe I can pose that question to you guys. Is this fine? Correct? We actually accept this. Do we accept this? Is this right? Or do we just simply open two brackets as per what we see, a plus b, the whole thing squared, and then begin to do what? Distribute. Okay, so that we get a squared plus 2ab when we've simplified everything plus b squared. All right, so please, guys, this cannot be wrong. We expand definitely, right? So this speaks then to something we need to fundamentally know and hold all the time, and that is this law here, a to the power m to the power n is equal to a to the power m times n, but it consistently works when the relationship of bases that are different inside the bracket are multiply and divide only. The minute you have plus and minus, that's separating bases. Doesn't apply. Okay, it's a danger. All right. Okay. Are we together, people? And you may feel like I've spent a lot of time emphasizing, but do you know how many problems you get exposed that are algebraic? And oftentimes, because this rule is taken for granted, we needlessly and carelessly apply a rule somewhere where the rule does not apply. Okay, so please, guys, I beg you with all of my heart and with all the energy of my heart that I can express, if you want to move from a place where you do not have this consistent, incessant, never-ending, season of silly mistakes, then please grab a hold of the little rules that you learn in mathematics. And just like what it says on my profile picture for this particular channel, maths is a game. Learn the rules. Master the rules. Be a master of the rules. Then when you play the game, guys, when you play it, distinctions will follow, because you are applying the rules correctly. And I'm sure some of you are realizing more and more that when you get deeper into the maths and you stop being surface level and you actually allow yourself to be immersed in the content, what ends up happening, you actually realize that, my goodness, this in actual fact, this subject just has a lot of rules. Some of us hate rules. Rules, we hate them. All right. But the thing is, they are a safety net for those that know them. Those that know the rules, these rules and laws serve as safety nets for those who want to acquire. Those who want to acquire high marks, they will get the marks and they will have access to other opportunities. Those who don't care about the rules, they will experience a very sick feeling in their stomachs because marks will not materialize. I hope you guys get the point that I'm trying to make. So let's come back here. Do you remember what I said, guys? What did I say? I said here, step number 1, whenever there's multiplication and division only in your exponential expression, the bases are numerical. You must convert your composite bases to what? To prime bases. And I told you how. You put what is converted in what? In brackets. Step number 2, I was saying apply the law number 3. You are going to find yourself applying this law. Why? Because you have converted. And by converting, it means that now you are going to have bases inside the bracket with something external to the bracket itself, the exponent. So now let's apply the law number 3. Look at this application. How many bases inside this bracket? 2 of them. So 2 needs to have a meal. And then 5 also needs to grab a meal. So let's take 2. 2 to the power is an exponent 1. We cannot see it, but it's there. But you know what? When we distribute that 1 into the x, we get x. We distribute that 1 to the 1, we get 1. Remember that in this particular scenario, you have a monomial exponent, which is 1. Monomial. Mono means 1. 1 term multiplied by x plus 1, 2 terms. So we do what? We distribute the 1 to the x, we get x. Because it's 1 times x. And then we distribute the 1 times the 1, we get 1. That's why 2 to the power x plus 1 is there. Times. What follows? 5. Guys, maybe you might wonder, why do I put a dot instead of a multiply? Remember, multiply and dot, you learned in grade 8 and 9 that dot and multiply in mathematics simply mean multiplication. Okay? So the 2 are interchangeable. Doesn't matter which one you use. 5 to the power 2. Same thing. We do what? We multiply, we distribute. 2 times x, 2x. 2 times 1, positive 2. Okay? Yes, grade 11, precious. Over Akuchi. Look at the numerator, at the denominator. 2 to the power x plus 1. This is fine. Times. Look at the 5 to the power 2. We distribute it as well. Applying law number 3. Law number 3 is applied because we had changed bases, guys, for certain numerical bases. The 50 we changed, having to apply law number 3. The 25 we changed, having to apply law number 3 of exponents. 5 to the power 2x plus 2. And please distribute through for all the terms. Sometimes people distribute the 2 and the x, they forget to distribute the 2 times the 1, and that's where the danger is. Step number 3 now, after applying law number 3. Step number 3. Yes, user, you are allowed if you want. You can screen record. I don't have a problem with that. And then maybe what you can do is that, you can send me those snippets of those screen records because unfortunately I don't screen record myself. Okay. Precious Akochi. How did I get 2 times 5 squared here? It was step number 1. Whenever there is multiplication and division alone for an exponential expression, I said we must convert composite numbers like 50 and 25, because those are numbers that have more than 2 factors. We must convert those composite base numbers to prime base numbers. Okay? How? Take calculator, press 50 in the calculator once it's on, of course. 50 you press, there it is. You press equal. You press shift after that, SHIFT, then you press fact. Remember, shift allows you to access the yellow things. Therefore, we have 2 times 5 squared. That's where the 2 times 5 squared comes from. It was my mission to convert composite bases to prime bases. I converted the 50 to that. I converted the 25 to 5 squared. Put it in brackets, please. Why? So that can allow you to use law number 3. For what? So that you can distribute. Okay, law number 3 of exponents tells us that when you have a base raised to a certain exponent and there's an exponent on the outside, you simply keep the base and you multiply the exponents. Same thing, if you have the bases multiplied and they are different, you simply keep those respective bases, you multiply the exponents. If the relationship between those different bases is divide, you simply keep the base and you multiply the exponents. If the relationship between the bases is plus and minus, no, you do not multiply the exponent. You do not multiply the exponents if the relationship between the bases is plus and minus. It is not allowed. It is not the law. It is not the rule. You will be going against the grain of the law, and the law will come down on you. So of course we do not do this. We don't multiply if there's plus and minus between. Okay? Rather, if you remember, and I use this example, if we have a plus b, the whole thing squared, we don't say a squared plus b squared. We don't distribute or multiply the exponents because there's a plus and a minus. We don't do that. It's wrong. But rather, we'll open the number of brackets that are there. And then we will do what? We'll distribute, foil, if you will, if it's to the power 2. I mean, we'll do what needs to be done. We'll open the number of brackets. If there was like terms in between, we'll add those like terms. Okay. So yes, bod mess and bad mess and bod mess and bad mess and bod mess apply. Okay. So thank you guys. I hope you get the point. Back here now. I cannot go back, guys, and explain again. If someone joins in and they've missed that part and that portion from the beginning, I will not be able to go back. You're more than welcome to go and subscribe to my YouTube channel, though. You go to my bio, you go and click on the link, the one that is the YouTube one, not the WhatsApp channel, the YouTube link, and then you can be able to see the explanation for yourself at another time. I am proceeding. So we've now applied law number 3. 2 to the power 1 can be distributed to x plus 1. Monomial, this one, times a binomial, this x plus 1, means 1 times x, x. 1 times 1, 1. X plus 1 is an exponent for 2. 5 to the power 2, you distribute. 2 times x, 2x. 2 times 1, 2. Base, 5 to the power 2, x plus 2. Done. Numerator, finished. Go down to the denominator. 2 to the power x plus 1, already there. It had a prime base. 25, we changed it to 5 to the power 2, so we distribute the 2 times x, 2x. 2 times 1, 2. Let's not forget to distribute completely, guys. You feel me? We distribute completely. 2 times x, 2x. 2 times 1, 2. Now, look at the beautiful place that we see ourselves in. The relationship between the bases. 2 is multiplied to 5 divided by 2, which is multiplied to 5. Obviously, there are exponents being there. The relationship is still multiply and divide. What does that say to you? Step 3, apply law 1 and 2. What does law 1 and 2 of exponents say? Law 1 and 2, law number 1 says, if bases are multiplied, same bases are multiplied, you keep the base, you add the exponents. This is assuming that these bases are all in the same position. If they are in the denominator together, you keep the base in that denominator together and you add the exponents. Are you with me? Yeah. You keep the base A, you add the exponents. This applies for what? For same bases. That's law number 1. What about law number 2? Law number 2 says, if you are dividing same bases, what do? You keep the base, you subtract the exponents. M minus n in this order. Alright? The relationship is divide and multiply. Now, listen to me and listen to me well. In applying law 1 and 2, we are going to note the bases. And once we note the bases, we look at the same ones. Same ones. Note the bases. Come here. Which bases do you note here? The first base is base what? It's base number 2. You feel me? I hope you feel me well. The other base is base 5. You feel me? I hope you feel me well. These are 2 different bases. But if you look at the bottom, wow, base 2 has a twin. Base 5 also has a twin. Doesn't that feel so good? I hope it does, guys. I hope it does. I hope you can see this, guys. I hope you can see it very well. It deserves to be seen. Okay? So this is for this particular question. So the way we're going to finish it off then is to identify base 2 first and foremost. Are you with me? Then, after identifying base 2, okay, we then collect x plus 1 from the numerator. But look at the relationship between this base 2 and this base 2. They are divided. So of course then, what we would say is we would say minus what? This binomial. And this is important, guys. This is a binomial. So if saying as though it's a binomial, we are going to say brackets x plus 1. You may have noted that some people actually do the following. They say 2 to the power x plus 1. When they go down, they simply say we change all the signs in the denominator of this exponent. So that means this is minus x. Now, I'm sure you understand why. What's minus times x? It's minus x. Minus 1 if you change the sign of the second term in that exponent. Because negative times positive 1 gives us negative 1. Okay. Are we together, guys? I hope we are. That's base 2 collected. Okay. So some people don't even write the step. They simply move from here to this directly. Why? Because some people simply write 2 to the power x plus 1. And they take it that all the denominator exponents will simply do what? They will change the sign when they go to the numerator. Why? That's because of law number 2, which says if you are dividing same bases, what do you do to the exponents? You subtract the exponent. Top minus bottom. Top exponent, x plus 1. Bottom exponent is x plus 1, but that means we change the sign of each term exponent. X now is now negative, but it was positive. Positive 1 is now negative. And that's base 2 taken care of. Times 5. We do the same thing with 5. We collect the exponents. That's 2 to the power x plus 2. The numerator base with its exponent. But since we are dividing, what do we then do to the exponent that follows? we would say 5 to the power 2x plus 2 minus, then in brackets, 2x plus 2. But what do? We distribute the negative. So it's negative 2x negative 2. Feel that? And then finally, okay, and that's why we have everything on one line, guys. Everything is on one line because we've applied law number 2, okay, and 1. Then 2 to the power, let's write x minus x is 0. What's 1 minus 1? It's also 0. And obviously 0 plus 0, that's 2 to the power 0, which is actually equal to 1. Let's move on to 5. Let's check what 5 says. 5 to the power 2x plus 2 minus 2x minus 2. Let's look at the like terms. 2x minus 2x gives us 5 to the power 0. What's 2 minus 2? That also gives us 0. What's 0 plus 0? That simply gives us 5 to the power 0, which is also equal to 1. Now what is 1 times 1, guys? It's simply 1. Okay. And seeing as though this is a unique question that I twigged a little bit by writing 25 to the power x plus 1, that is why my answer is eventually 1. Okay? Alright? But in essence, guys, do you see what we do? 2 to the power 0 to 1. There is a law. There is a definition of exponents that says any base raised to the power 0 is equal to 1. Okay. Any base raised to the power 0 is equal to 1. Okay. So this is a definition of exponents. It's a definition that you need to know. You usually get introduced, and you got introduced to this definition in grade 8. Okay, when you did grade 8, you guys learned all the laws of exponents, and you also did the definitions. A to the power 0 is equal to 1. So you know that anything raised to the power 0, with the exception, of course, of 0 raised to the power 0, but anything else raised to the power 0 is equal to 1. But it has to be that that particular thing is positive in order for it to be positive 1. That's very important. Okay. So we need to understand that a to the power 0 is equal to 1. Okay. And I just want to check. Look at this. Look at this. Can someone tell me what's 2 to the power 0? Seeing as though now you know this definition, what's 2 to the power 0? Anyone can tell me in the comment section what's 2 to the power 0, guys? Okay, Woman of Faith says 1. Yes, Gift. The thing is, I made up a new question, right? It's not the same question as you guys got in the group, right? Yeah. Okay, I just wanted that to be slightly different from what you guys did there, so that it can be something unique to the live. Okay. But what is the point of this whole thing? It's so that you understand the steps that you need to take when you are doing what? When you are simplifying a exponential expression that has multiply and divide alone. Okay. So someone tell me 2 to the power 0. I see everybody says 1. Let's ask. Here's another thing. What about negative 2 to the power 0? What's the answer? Tell me in the comment section. Thank you, God Goss. Really appreciate the compliment. Negative 2 to the power 0. Mambana says negative 1. Bless says negative 1. Woman of Faith says 1. Anika says negative 1. Steezy says negative 1. Good people, listen to me and listen to me very well. So the negative sign. Yes, Woman of Faith. Man, Woman of Faith, I could right now. You give me reason to want to celebrate. You understand why you are wrong. How important it is, guys, to understand why you are wrong. Because once you understand why you are wrong, then you will know what to do the next time. So, guys, here's the thing. Who 0 as an exponent is affecting who? 0 as an exponent is affecting 2, the number, but the sign is unaffected. So this is like us saying this is negative, the 2 to the power 0 is 1. So the answer is negative 1. Okay, because as you rightfully said, my amazing friend, woman of faith, different story if it was minus 2 to the power 0. Okay, so 0 affects only the digit, but not the sign, because the 0 is above the 2, but not the sign. It does not affect the sign in this particular instance. So negative 2 to the power 0 is equal to negative 1, guys. The sign is still negative. The 2 is affecting, the 0 is affecting the 2 alone, not the sign. Okay, this is what it means if you write the number exclusively. So it's like here, a to the power 0. Okay, the a is actually a positive, but the 0 is affecting the what? The a. So a to the power 0 is 1, but it's positive 1, right? Because this was positive. 2 to the power 0. Okay, the 2 to the power 0, it's positive, right? But the 0 is affecting the 2 alone. So 2 to the power 0 is 1, but it is positive 1. Negative 2 to the power 0. Again, the 0 is affecting the 2, not its sign. So therefore the answer is negative 1. Look at this one. Now this is a completely different story, guys. Hey, this is a completely different story. Do you know why? Because look at this. What is 0 affecting? 0 is not only affecting the number 2, but is affecting its sign as well. Hey, and you guys then ask me the question, why do I always say S and L? And I say to you, stay away from these movies. Stay away from these movies, these ones. S and L. If you are seeing a TV screen and you see these letters, stay away from these movies. But, this is a good indication that focus on the, I say S stands for sign, this stands for number, and L, you know what it stands for, but sign, number. So we always need to consider when dealing with exponents, who is affected. So here in this particular instance, the 0 is affecting everything, the sign and its number. Are you with me? Now here's the thing, listen to this. Here's another revelation. 0. Guys, do you know that 0 is an even number? Yeah, it's an even number, this number. 0 is an even number, eh? And do you know what even numbers do to negative signs? Hey, maybe you need to ask yourself, woman of faith, the reason why I'm saying 0 is an even number, ask yourself, what is an even number? What is an even number by definition? You know? Yeah. So the thing is, this 0, yes, is affecting everything. The bracket encompasses the sign and the number. So therefore, when we apply this 0, okay, any Erasmus, you have been answered by Amor. Thank you, Amor. So minus 2 to the power 0, that is affecting everything, the sign and the number. So that there is equal. An even number does what to a negative sign? It changes the negative sign to what? To positive. Then 2 to the power 0 is actually 1. So the answer here is positive 1, because it is in brackets. And that's why, guys, you cannot fight with Mr. Calculator. If you do this, for instance, look at this thing. If you do this, okay, because I know some of you are fighting inside your soul. You remember I said minus 2 to the power 0, and I told you minus 2 to the power 0 to negative 1. Then you say Mr. Calculator is wrong. Look at this. Do you see this? Do you see this? Do you dare fight here with Mr. Calculator because you trust him more than me? Yes, woman of faith. Every even number will change the negative sign to positive. Every even exponent will change the negative number to positive. That's if that even number is encompassing the sign. But if the even number is not encompassing the sign, it does not affect the sign. That's why I'm saying to you, in this situation, the 0 is above the 2, but not affecting the sign. Are you with me, guys? So the negative stays because the 0 is not affecting the sign. But in this situation, the even number 0 exponent is affecting the sign and the number. So therefore the answer is positive 1. That's why your calculator, hey, do you see where the danger is? If you don't put the brackets, hey, and the brackets are supposed to be there, hey, if you are even substituting into the quadratic formula, you are busy there substituting into the quadratic formula, the b value is negative, and in that b squared you don't put the bracket. Hey, do you see where the danger is, guys? Hey, yo. And then you don't understand why when I change things I put them in brackets and all of those things. Brackets, guys, make a difference. Okay? And then check this out. Let's change this now and put brackets around everything. And look at this now. Hey, you see your calculator? And this is your calculator. It's not me now, because some of you, I know you're fighting with me. You're like, hi, money, this guy, yeah. All right. So I hope you get with this thing. Okay. And those people who are joining in and who are having all these other comments, please, guys, understand these are high schoolers. The high schoolers are learning certain things, and unfortunately, maybe when you are at a higher level of understanding and all of those things, for now, in this world of ours, 0 is a whole number, and it is a number, guys. 0 is a whole number. We call it a whole number. Because whole numbers are numbers that start at 0, they increase by 1 up until infinity. So allow us to be in this state for now. Those who are advanced and who are coming and commenting in the comment section, that time will come for them. Please allow these kids to actually take things at paces, at a pace that is reasonable, so that they can be able to ascend. You know what I mean? Yeah, let's do that, and then in due time. Okay, but I hope I've driven my point home, people. Important definition, this one. Important. All right? So let's get it right and understand it for what it is. Otherwise, there will be dangers we will have to face. Okay? Please understand the reason why we don't say the answer is 11 is because, remember, the relationship here was one of multiplication. Okay? Do you see what I mean? The relationship was one of multiplication. Does that make sense now? So therefore 2 to the power 0 here is 1, but the relationship, remember, between the bases was multiplying. So we say 1 times 1. We don't say 1 and 1, 11, the answer. Alright, guys, come on. Right? 1 times 1 is 1. That's the final answer. Alright, I hope that was fruitful. I mean, that was a problem that was explained, and I've dissected it so that I can actually bring in these other things that are basic, right? I mean, usually when I explain a problem, I just go into it and I just explain. And I run through things as if like you guys all know I'll talk of prime bases and people won't say a word. I'll say composite bases. People don't even know what a composite number. They don't even ask anything, and they're like, until the end. And then I say SNL and people think SNL, I don't know, maybe they think I'm talking about a particular TV channel or series or or anything of that nature. But all in all these things have meaning. Okay, and once we know those things and we can apply them, consistently, consecutively, consistently well, then the maths will pop. It'll pop very well. Okay, now I want. People are asking me about a group of study. No, I don't have a group of study, my leader. Why you want me to have a group of study? I don't have a group of study, but I just have these TikTok lives that I'll do every once in a while. The thing is, I have my own class. That's the thing. Hey, I have my own class at I have my own class at school, and they also need me to be very much available. Hence, I cannot avail myself as fully as I would want, and these things are every once in a while. Yeah, I'm busy there, cooking. Hopefully, next year when I announce, I'll be able to announce to you how well my class did, and then you guys can also enjoy the supreme results. You know what I mean? And during the weekend, I actually interviewed one of my good friend colleagues who actually had I think a grade 12 class of 87 learners, and 43 of those learners got distinctions in his grade 12 cohort group. The lowest level from that group of that grade 12 learners was a level 3 that a learner got. Everybody else got above level 4. And I was like, hey, this guy, yeah, he's put up a high bar for people to actually, pass. So, yeah, these are some of the things that, we are surrounded by such colleagues, and it's so nice, always shooting for excellence and nothing else. So 9 to the power n minus 1 minus 3 to the power 2n minus 3 over 3 to the power n minus 1. So here's another problem. And this time round, we have, you can see division because of the line. All right. But at the top, we have subtraction. Now, here's the thing. When there is either addition or subtraction, that number one, Abu, is a very familiar, but obviously not, I think you guys have been exposed to this problem too many times for your own liking. But it's just that I changed it up here, and I just put x plus 2 instead of x plus 1. Instead of x plus 2, I put x plus 1. Just so that it could be unique for this live session, okay? So familiar problem, hey? Familiar, I'm sure, okay? So it was just that. But that was a problem that only had multiplication and division, and obviously there is a method that is attached to that, which we have gone through. Changing composite bases to prime bases, applying law number 3, which only applies for multiplication and division between bases, applying law number 2 after that, okay, collection of those bases, addition and subtraction of like terms, making sure that the division exponents are expressed with different signs, the denominator exponents are expressed in different signs to the ones that they had, then adding and subtracting like terms, and then simplifying and getting the answer. That is like standard, the procedure we tend to follow for the multiplication and division of bases that are numerical. Then the next level is to look at when there's addition or subtraction. You are very welcome, Abu. You know Moss. You know you. Addition and subtraction of when there's addition and subtraction between the numerical bases. Slightly different approach that we take here, but there's similarities, okay, that we can actually still see even in this problem. So this particular one, this problem, there's a 9 there. We can convert the composite base to prime again. Thank you, Kosi. How kind of you. Very kind. Thank you so much, Kosi. 9 we can write as a prime base. 9 can be written as 3 squared. And we just raise it to the power n minus 1. You remember, all composite bases that we change to prime bases, we write them in brackets, and then we write n minus 1, the exponent, external to that. Okay, so this conversion of composite to prime, it seems to be something that is a recurring theme. This one is already prime, so we don't have an issue there. Look at this at the denominator. In the denominator, we have 3 to the power n minus 1 squared. Yeah, and this here, all right, means we have a binomial just with the monomial on the outside. So we are applying law number 3. Okay, hopefully that's clear. Are we not supposed to write 3 times 3? B. Okay, remember, me as your educator, I use this 3 times 3 is the same thing as 3 squared, but for the purpose of like what I had explained to you earlier on, it's always nice to write your prime bases, your in exponential form. So we usually press 9, we press the equal sign, we press the shift, we press the fact. Otherwise, we are basically speaking about the same thing. You're just writing 3 times 3 as a product. I am writing 3 times 3 as a in exponential form, so that I can be able to utilize the distribution of the monomial by the binomial. So that's why there's this sort of like strict approach of ensuring that I keep this 9 in exponential prime form, not as 3 times 3, but in exponential prime form. It will make it for easy factorization, because the minute we have a minus or a plus, we know that law number 1 and 2 will not be able to apply law number 1 and 2 where we keep the base and add the exponents, because remember, we only do that where there's multiply and divide between bases. But look, this 3 to the power 2 and this 3 to the power 2 are separated by a minus sign, which means there needs to be some other approach completely of factorization. And in our heads, we are like, there's multiple types of factorizations we have learned so far. There's highest common factor, where we take out a common factor. There is difference of two squares. There is trinomial factorization. Yeah. Okay, so that's very important. So here at the bottom, apply the law as well. Binomial by a monomial. So the 2 we multiply by n gives us 2n. The 2 we multiply by -1, we get -2. Okay, and that really goes down well. It's like a dish. Prime base, we changed composite to prime, and we've applied law number 3 in the denominator. Oh, Mr. Fa, I really appreciate that beautiful rose. With that blue taxi of yours in the profile picture, you got is that you, or is it just a pipe dream, or what? 2 times n, we distribute 2 times -1. What's 2 times n? 2n. 2 times -1, -2. Gaming account. Oh, awesome, man. Awesome. Then 3 to the power 2n here, -3. Over 3 to the power 2n, -2. Thank you so much as well for those ice cream cones. Really appreciate those. Guys, now look at this. Some people get tempted to want to, they see this, they see that, they're like, oh, they are the same. They say, hua, hua. And then it's like, goodbye, Marks. Goodbye. It was nice knowing you. And then the marks just go, bye-bye. We were doing so well. But you decided to cancel across a subtraction sign. We don't do that. Guys, we don't cancel across a subtraction sign. And some people, they just go, hua, hua. And then they, hua, hua. And then it's like, no. They're like, no, they are the same set. This one, hua. And then they say, hua. And then they leave it. And they're like, hua, this is left behind, say. Okay, so we don't do that. So the whole key here, no, because I relate, Mamba. Oh man, I see this also so much. Like, it doesn't matter how many times, like, you'll never not see things like that. Because in life, just like in like there's laws and rules, there's people that always want to sort of like push the limit, or they want to do something that's never been done before, or they think, or their interpretation in the head, they kind of remember that there's something about cancellation when it comes to mathematics generally. But the thing is, there's laws to cancellation. You cannot just cancel. You can't cancel across a subtraction sign or an addition sign. Okay, yeah. So that is the thing. But so there at the top, there's this thing that if you see here at the top, but before we do that, there are people that know that if you want to take out something, you need to first split. Splitting is not a good thing for some people. Some people don't like splitting. They want to be together. And therefore, when they are together, all right, so for instance, there's a grade 11 learner in my life at the moment who is together with someone. They know that being together with that person is only wasting their time, and their heart is basically just sinking and sinking even more. What they need to do is leave. They need to split with that person so that they can be able to experience the joy of simplification in their life, so that they can be progress in their academics. But they want to stay there. So not splitting is a problem, So sometimes you have to split to simplify. No splitting, no simplification. Okay? So if we split there 3 to the power 2n, I see no, that's fine, Democrats. I'm very glad. When you see your mistakes, me, I'm very happy. I rejoice, Yeah. Hopefully, and this is the beauty of it. That's why, for instance, I'm speaking to some things here that, we tend to do. Okay? Yeah. So now here, we are in this situation, we split. Do you know that in my head, the reason for splitting even more is seeing that if I look at my variable exponent, all right, the n, and I look at this n, I can see that the coefficient for both are to the power 2. They have a coefficient of 2, both of them. So that's why there is some sense of commonality that is there. Something that I can take out. Does that make sense? Yeah. So we split to simplify, guys. Hey, did I just drop some some good advice for some people right now in the live? We split to simplify. You're a grade 11 learner, you must split to simplify. Okay? The time is not there for people now to just, Anyways, in the numerator, now we can take out the common factor, 3 to the power 2n. But now we are left with 3 to the power negative 2 minus 3 to the power negative 3 over 3 to the power 2n and 3 to the power negative 2. Okay. Yeah. So when there's addition and subtraction, it follows that there's always some type of factorization that has to take place. How do you quickly identify that it's highest common factor factorization? You identify that simply by seeing that for the same base, there is a variable, for instance, sometimes, that has the same coefficient. Because if that's the case, by splitting, you can take out that base with its what? With its variable exponent. Okay? And then you can simplify. Okay? So it's very important, guys. That's why we split. Because this question, like I said in the beginning, is addition and subtraction. Please, guys. In the previous question, do you remember, we did not have subtraction and addition between bases. We only had division and multiplication. So applying the laws was just straightforward. You know what I mean? It was so straightforward. But the moment you have addition or subtraction, this is a new problem. It's a fresh scenario. It's a new scenario. That means it needs to be approached differently. Okay? It has its own sort of like, it's his own unique approach that we have to apply into this problem, which is very important. Okay? So therefore, we apply that uniqueness. All right? And like I said here, okay, we converted our composite bases to prime bases, and then after doing so, we distributed what needed to distribute. Then we saw that, hey, there's a need now to actually do what? To split. Why? Because this minus sign, we cannot use law number 1 and 2 when there's a minus sign. We can't do that. All right? So therefore, we need to then approach it in that fashion. We first split, and then we can factorize. You know what I mean? We split and then we can factorize. So we take out that common base with that unknown variable. And there it is. The common base here, 3 to the power 2n and 3 to the power 2n. We take it out. We are left with what in the left? 3 to the power negative 2. We are left with what in the right? 3 to the power negative 3. Yabo. So it's very important, people, when there's an addition and subtraction sign, please listen to me and listen to me well. When there's an addition and subtraction sign between bases, you must at some point factorize. Okay, and the thing is, you need to look at that particular problem. For some problems, splitting will lead to highest common factor factorization. Some problems, there might be another type of factorization that you may have to apply in that particular problem. Problems are not the same, okay? Problems are not the same. But one thing you need to note is that if there's an addition and a subtraction sign, you cannot apply law number 1 and 2. You have to factorize. At some point, something needs to be factorized, okay? All right, so let us continue so that we can see then what do we do with these beautiful people. Because now, look at this. At the top, we literally now do not have separate terms. We have one term in the numerator and one term in the denominator. That then allows us, okay, nine. I think I need to suggest to Uboipelo Selo. I think Uboipelo Selo is an individual that could easily do live sessions as well in this platform. If you can see, Mr. Boipelo has 186 followers, and I think that page of his could quickly exponentially grow if he could open a platform. I can see he's recommending some nice things in the comment section, things that the people who are in that particular live would benefit a lot from, you know. Maybe you need to consider it, Mr. Selo. I think you should really consider it, my brother, so that the South African masses can enjoy, you know, that mathematical knowledge. I think there's a lot of people that are here that could do that. Don't fear to start. I think this is the message for you. Don't fear to start. Just start, and you'll be surprised at the impact you can have on the nation, you know. All right. Okay, so just continuing on, I'll just wrap it up, and then if there's anything that people want to ask, I can basically go back and entertain those questions. So 3 to the power 2n, like I said, and this bracket are one term, and this in the denominator, because of multiply, is also one term. Okay, now guys, what's beautiful is that you can say hua, hua. Do you know why? Because, guys, this is officially one term. Okay, 3 to the power 2n, that's a base multiplied with this entire thing here. So the cancellation is feasible now. You know what I mean? We can do it because it's not across an addition and subtraction sign. It's one term at the top, one term at the bottom. So cancellation is now feasible. We could not do it earlier on here because this here at the top was not one term. These were two terms separated by a subtraction sign. So therefore we could not cancel at this stage. Not at all. It would be wrong, and it would lead to our demise. We would be losing unnecessary marks because of that. So here though, one term at the top, because brackets combine terms. This is one term at the top. This here is multiplied by this entire thing. So this can be cancelled with that. Okay. Just something to note, you cannot cancel 3 to the power negative 2 and 3 to the power negative 2 because this 3 to the power negative 2 is still across this subtraction sign to 3 to the power negative 3. So these cannot be cancelled. It would be completely wrong to cancel these two. Mathematically, it is incorrect. We cannot do that. But this and that, definitely, we can cancel those two. Okay, they stand independently from that, and then this is actually there as well. We can cancel those two. Are you with me? And then what are we left with? Was 3 to the power negative 2, 1 to the power 1 over 3 to the power 2 minus 1, 3 to the power 3. Now someone may be asking how. Listen guys, a negative exponent a to the power negative 1 is equal to 1 over a. And negative exponent a to the power negative 2 is equal to 1 over a squared. And negative a to the power negative 3 is equal to 1 over a to the power 3. So all in all, what are we doing? We move the variable to the denominator, and then the exponent changes from whatever sign it was to positive. And then what gets left at the numerator at the top? We are left with the coefficient of a to the power negative 3, which is 1. So that's why the answer here is 1. Where does the 1 come from? The coefficient of a to the power negative 3. Where does the a go? To the denominator. There it is. What happens to the negative 3? It becomes a positive exponent in the denominator. Okay. Same thing here. A to the power negative 2. There is a 1 there. It's always there. A to the power negative 2. A goes to the denominator. Exponent sign changes from negative to positive. What gets left at the top? 1 over 1. 1 gets left at the top. So it's 1 over a squared. Same thing here. Who is in the coefficient? It's 1. Who gets left behind? 1. Who goes down to the bottom? A. What happens to his exponent? Negative becomes positive. So the answer is 1 over a. This here is also another definition. It is a definition that applies to negative exponents. Now, do you understand why 3 to the power negative 2 all of a sudden is 1 over 3 to the power 2? Why 3 to the power negative 3 is all of a sudden 1 over 3 to the power 3? And then in the denominator, I have 1 over 3 to the power 2. Make sense? All aboard, all aboard. Do we all understand? And how important it is for us to see this part. The fraction, that then emerges. Okay. And good people, in all goodness and generosity, there is allowance here that at this stage you can actually just simply take your calculator so that you can reveal what is the numerator value that you get. You can say 1 over 9, and then you can say plus 1 over 27. They give you that allowance. Then you can write the numerator a fraction, which is 4 over 27. There it is. Divided by, you can say divided by 1 over 9. You know that 4 over 27 divided by 1 over 9 can be written as 4 over 7 times 9 over 27, which I'm sure you can see is 2 over 3. And that is exactly what it is, 2 over 3, because 9 goes into 27 how many times? That's the answer, right, guys? 2 over 3. So the answer is 2 over 3, right? Why did the negative change to the positive? Okay, very good, Kumo. I just wanted to actually... Yes, so it's not... It's 4 over 3, definitely. Okay. Nokwanda is asking, why did the negative change to positive? Yes, it's 4 over 3, guys. I just wanted to have someone... tell me the actual answer. Okay, so it's 4 over 3, definitely. So you were asking, Nokwanda, why did the negative change to positive? Which negative? You mean the negative exponents? It's because, guys, there's a thing about exponents. We cannot leave the answer as a negative exponent. So for that, there's actually one of the definitions of exponents that says any base raised to a negative exponent can be written as the coefficient in the numerator with the same base in the denominator raised to the same exponent, just with a different sign. Okay, So it's 1 over a to the power 4. So what I did is I took 3 to the power negative 2 and I wrote it as a 1 over 3 to the power 2. 1 over what? 3 to the power 2. I applied this particular what? This particular definition. Okay. Okay, does that make sense? I applied this definition. Same thing with 3 to the power negative 3. What did I do? I simply wrote it as 1 over 3 to the power 3, applying this definition. Okay, this is a definition in mathematics that you need to know. It applies for negative exponents. You want to express negative exponents as positive exponents. You don't want to leave your answer as having negative exponents. Okay, and then again, 3 to the power negative 2 can be written as 1 over 3 to the power 2. That's also applying this particular law. All right, and then basically at the end of the day, what's 1 over 3 to the power 2? It's 1 over 9. What's 1 over 3 to the power 3? It's 1 over 27. And then what's 1 over 3 to the power 2? It's 1 over 9. And then from here, really and truly, guys, 1 over 9. Oh, yeah, there we go, Gift. Thank you so much. Gift actually found what error I had made. Do you remember this was actually minus? And he definitely, Gift, I was supposed to have written minus instead of plus. That's where I went wrong. Thank you so much, Gift. You are a gift to mankind. Okay, so let's change that up a little bit. There it is. Let's just change that sign to plus. Now that was a complete slip and a mistake and an error, and I'm not ashamed to actually admit that was a real error from my side. So apologies. Yeah, I did not claim perfection. I do claim that I do try to assist and help, but yes, I definitely make errors myself. So yes. So 1 over 9 plus 2 plus 1 minus 1 over 27. So let's just remove the plus sign, because you see I changed the negative to positive. And I guess that's what why did the negative change to positive? Oh, so that's what Nokwanda was asking. And Nokwanda was asking a very key question there. It's just that I did not understand what sign she was referring to. Nokwanda, I'm very sorry. Thank you very much. I hear you there. So we that negative does not change. It cannot change. It has to stay that. So it's 2 over 27, and that ultimately gives us that 2 over 3 that we are speaking about. Okay, thank you so much. Thank you so much. Nokwanda is like, yes, yes, indeed. Thank you. Thank you so much. That's very kind. Very, very kind, Nokwanda. I think Nokwanda deserves a round of applause and gift as well, eh? Gift, thank you, man. Yo, yeah, that was a shooting of the shots. Kumo was asking me to give a problem and actually then wait for you guys, and then we mark together. Kumo is like having reminiscent moments of being in a classroom set up with his teacher and that being done. Okay, let me look for a problem so that you guys I can give you one, you can do it, and then we'll do what you want, Kumo. Kumo's special request. Oh yeah. Kumo. Oh my soul, Kumo. What a name, eh? Kumo. What does it mean, Kumo? What does Kumo mean? Eh? And is it Tswana? Is it Tsonga? Is it what is it? What is it? Is it Chinese? I can just see Kumo like trying to type away and explain what his name means. He's probably giggling as well whilst he's doing it. Okay, let's see. Yeah, Chinese indeed. Okay, let's see. Yeah, you never know, eh? Chinese, you know. Ah, yeah, oh yeah, oh yeah. You never know. Yeah, these guys are making so much crazy noise. Okay, here you go, Kumo. Let's see if you've got the method down. Never can, don't worry, I won't forget. I'm sure you guys are hearing the screechy noises from my little ones in the background. Yeah, I don't know, they're just having so much action. So animated. 3 to the power x plus 1 minus 3 to the power x plus 2 over 3 to the power x minus 3 to the power x minus 1. Okay, so like Kumo said, I'm giving you 2 minutes. Is it 2 minutes, Kumo? Did you say 2 minutes? Let's see. What did Kumo say in his thingamabob there? Do you mind give us one more? To then you wait 2 minutes, then we mark together. Okay. The YouTube channel is called Maths is a Game. You can go onto my bio. The link is there. You can just click on the link and hopefully it will send you to greener pastures. And it's just these live sessions, guys, so far, the majority of them. There's a playlist that's actually been, I guess it's there now, playlist for grade 11s. It's basically made up of all these live sessions that I've done since December, okay? And like, yeah, we started with Exponents since December with the group of grade 11s that were there then. Because some of y'all were having a good time, you know, festive vibes, and we were just like mathsing it away, doing exponents. We finished exponents, and that group will know that I sent them a test. They wrote a test, and then yeah, like Gift, whom I think is here somewhere, he was the one that actually fixed the plus sign that I supposedly changed. Seems to be very much taking particular attention, always paying attention to detail, Mr. Gift there. So Gift actually like killed my test, and he got 100% for it. It was out of 50, right? 1 hour, 50 out of 50. And I was like, yeah, at least that means concept received, concept assimilated. So I'm only waiting for great things this year from Mr. Gift. He must just continue doing the things, eh? Hopefully he will be reporting on the 100% as the terms go by. That's basically what I want for most of you guys. It's just yeah, man. Just do the things, man. Do the things in maths. Kill it. So aren't you supposed to say 1 over 9 minus 1 over 27? You see things like that. Yeah. When you know what you know, correct me. Don't ask me. I know you want to be kind. Just tell me, sir, you messed up there. Change it up. Change that. It is sickening. No, I'm just kidding. Yeah, but I appreciate that, the correction. It's always nice. So those who are joining in, the people have asked that I give them a problem to do, so they are busy doing it. I am allowing them time to do it so that they can see if they have captured the concept that we had explained a bit over and over again. So let's see if people will be able to maneuver nicely and get to the beautiful answer. All right. And I'm guessing people will indicate in the comment section, done, if they are done, so that I can actually at least get an indication of how many people are sailing and flowing through. And then we will proceed to do the correction together. Amo 1 is done. Okay, we've got our first customer who's done. Oh, Annika is also done. Nice. Yolanda is also done. Boca is done. Gift is done. Yeah. Let's wait for the man himself, the person of the moment, sorry. Oh, Kumo is done. Nice. Neat. Kumo, wait, maybe you can tell me in the comment section what's your answer. I just want your answer. Only Kumo, please. No other person. I don't want your answers. I don't want everybody else's answers. I just want Kumo to tell me what the final answer that they got is. Him say, he say. So Kumo, do you mind letting me know in the comment section what answer did you get? Final answer. Now that's gonna expose you, right? Because now you are actually supposed to comment in the comment section and write, I got 2 if you did get 2, or I got 7, or my final answer is this. So we're waiting for Kumo, guys. Kumo is going to give us the answer that she got. Or is it a he, or is it a she? Oh, Kumo, we want your answer. Hey, I got 4. So Kumo got 4. Okay, let's see what the grand jury also got. You guys can type your answer, your final answer. What did you get? I just want to see the variety in the answers, and then we'll do the correction together. Let's see. Come on, drop your answers, guys, in the comment section. What did you get? Sure. Okay, Gift got -9. It's like there's a hesitance from people to write their answers, eh? Hesitance. Aisha got -9. Tumas got 9. +9, that is. Mr. B. Is it Mr. B or is this Miss B? Oh, it's Amahle, sorry. Amahle Zita got -9. Guess when you've got that kind of name, Amahle, you definitely have to get a beautiful answer as well, hey? Goldie, 19, got 9, -9. Mabongza got -9. Lesedi got 12/3, which I'm guessing the 12/3 is also 4, just like, Okay, Thomas, it just fixed, says it's a -9. Okay. Alright, then we'd have to accept, guys, that the finale answer definitely is -9. Okay, because the majority said -9, right? So they must be right, of course. Yeah. Okay, so let's look at this, guys. Top, bottom, minus, minus. So we know that this is negative, so it means there will be some sort of factorization or taking out. Some sort of factorization will be happening. Let's just put it that way. Okay. Whether it's highest common factor, trinomial, difference of 2 squares, that's something we are yet to discover. But one thing we can note is that we can see there's a base 3, there's no need. The step of converting from composite to prime is not even a need. So converting from composite to prime, no need in this situation. So our step 1 is not something we need to do. Step 2, what did we usually do? We would split. Split what? Split the bases. Split the bases, split so we can simplify. People who don't want to split must split sometimes. Splitting so that we can simplify life, simplify everything, make life easier for ourselves. So let's split. 3 to the power x, 3 to the power 1, 3 to the power x, and 3 to the power 2. We split at the top. You know what? At the bottom as well, because there's a minus sign, that means split at the bottom. Okay, are we together, guys, with the splitting? Split, 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 split. Though painful it is, sometimes you gotta split. Okay, do you see that? Okay. Step 2. Now, we can see that's 3 to the power x. There's also 3 to the power x this side. So here we have a common base with a unknown variable. At the bottom as well, common base with the same unknown variable. So at the top and at the bottom, we are going to be taking out. Ideally, we like taking out. So this is highest common factor, but the base with the unknown variable. Base with unknown variable. We can see that the coefficient for those variables are the same. We take it out. Okay. The unknown variable exponent. Hopefully you guys can sort of like ascertain and see that, because there's minus, and minus means we need to do that. What are we left with in the left? 3 to the power 1. Left within the right, 3 to the power 2. At the bottom, we take out 3 to the power x. What are we left with in the left? Now, 3 to the power x times what gives us 3 to the power x? We're left with 1 in the left, guys, right? Minus 3 to the power negative 1. You see? So simplified, so nice, so elegantly done. You know what I mean? Equal. Now we smoothly just sail through, guys. We sail through, all right? Because that 3 to the power x and that 3 to the power x, remember what I said? We've got one term at the top, one term at the bottom. Isolation chamber, same. Cancel, cancel, goodbye. What are we left with at the top? 3 minus, what's 3 to the power 2? 9 over 1 minus, what's 3 to the power negative 1? We can write it as 1 over 3. Finally, what's 3 minus 9? Negative 6 over. We can obviously use our calculator for this and quickly just get the answer, which gives us 2 over 3. Hopefully you guys can see that. 2 over 3. Then negative 6 divided by 2 over 3 means negative 6 times 3 over 2, which I'm sure you guys can simplify very nicely. What's negative 6? You change divide to multiply. What happens to the fraction? It inverts. Reciprocal. You know what I mean? And then you can simplify from there, guys. Really and truly, you get a beautiful answer of negative 9. So those who said negative 9, you guys are the best. Rock stars. If you made an error somewhere, do you see where your error is? If you got a different answer, do you see where you went slightly off the mark? I forgot to factorize the bottom. Okay. So remember that in the problem we did previously, that example, there was no what? Factorization in the denominator, but there has to be. Why? Okay. You can't identify your mistake. Look. Please, look. Let's look at the top. Just quickly. Remember what we did at the top and at the bottom. We split the top. 3 to the power x. Do you have 3 to the power x? Times 3 to the power 1. Do you have 3 to the power 1? 3 to the power x. Do you have 3 to the power x? 3 to the power 2. Do you have 3 to the power 2? Minus sign. Very good, Anik. I like the fact that you said check your sign. Check your sign indeed. There's a minus at the top. There's a minus at the bottom. And please take note of the numbers. 3 to the power 1. There's a 3 to the power 2. 3 to the power x. 3 to the power x. 3 to the power negative 1. Come down here. You take out the common factor. You're left with 3 to the power 1 on the left. Left with 3 to the power 2 on the right. Take out the 3 to the power x in the bottom. You're left with 1. You're left with 3 to the power negative 1. You cancel. Oh, the 6 is what? It's positive. So you said 3 minus 9 is 6. See, that's positive. But it's 3 minus 9, which is negative 6. Okay, very good. I'm glad you picked up on your answer, on your error, Lesedi. Okay, silly mistake, Lesedi. Does that mean you don't understand the method? Not at all. You understand the method so well, Lesedi. So I'm very proud of you. You know the method. You know what to do. But the only thing is that you made a what? A silly mistake. Please explain step 3. You mean here? You mean here? Taking out 3 to the power x? Taking out 3 to the power x. So remember here, we said what? We split. Okay, I said splitting is not nice. Some people don't enjoy splitting. We split here, 3 to the power x and 3 to the power 1. We split there, 3 to the power x and 3 to the power 2. The denominator, 3 to the power x. We split here, 3 to the power x, 3 to the power negative 1. Then at the top, what do you observe? You have 3 to the power x. It's common for two terms. You take out 3 to the power x. You are left with what on the left? 3 to the power 1. You're left with what on the right? 3 to the power 2. Because you took out who? 3 to the power x. You leave them alone. It's cold. Baby, it's cold outside. No, I'm just kidding, guys. Okay, so 3 to the power 1, 3 to the power 2. In the denominator, 3 to the power x you take out, you're left with 1. At the right, 3 to the power negative 1. Okay. Okay. Makes sense? Denominator. 3 minus what? 9. Over 1 minus, what's 3 to the power negative 1? 1 over 3. 3 minus 9, negative 6. 1 minus 1 over 3 to 2 over 3. Okay, this is calculator stuff. Just please, guys, reveal the numbers. Please reveal the fractions. Reveal them. Say wants to see 3 to the 3 to the power 2, 9. 1, 1. 3 to the power negative 1, 1 over 3. Let's reveal them. Let's reveal the numbers. Please, guys, don't just leave the exponents. Reveal the numbers. Then after that, simplify the respective numerator and denominator. You can utilize your calculator. It's fine here. You don't have to show that addition of fraction, subtraction. You can just say 1 minus 1 over 3 and write 2 over 3. Then, you know this is negative 6. Divide. Show it. Times it. Now answer it. Okay. Okay, guys are wanting more. Maybe I'll give you more if you feel like you want more. As long as I'm not getting backlashish. I'll give you homework. I just want to check something out here. Let me give you another type. Look at this, guys. What about this one? Okay. You see the thing is there are different types. So the example I just gave you is a certain type of exponential expression when there's addition and subtraction. So under your addition and subtraction types of problems, there's this type that I've just shown you. Here, this type, there's always a common factor. You're taking out a common factor. So it basically is looking at highest common factor factorization. Look at this one. This one. Yeah. Okay. Mambana says we factorize here. And you are right. But who do we factorize? And do people all understand in this live, the factorization that is applied? So I'm going to do this as an example and then I'm going to give you your own. So look at this one, guys. Now, some of you are going to be like, okay, 4. Key composite number. So what do we do? Change key composite number. Change to what? To prime. So let's do that. 2 to the power 2. Okay. Now you unfortunately cannot do more than that. Then look at this. Okay, we've changed composite to prime. Now, this here at the top is a certain type of factorization that we should all be aware of. There's a minus sign here. This is a difference. And then here you have 2 to the power. We can actually swap this around and say 2 to the power x raised to the power 2 minus 1. Now, if you are vigilant and aware, you will see that the numerator possesses, as people said. Okay. Yes, I love what you're saying, Precious. We take x in, we take 2 out. And this goes back to a concept in mathematics that you learned in grade 8, and that is multiplication is commutative. What does that mean? It means the order in which you place your factors doesn't matter where multiplication is concerned. The answer will be the same. So 2 times x is the same thing as x times 2. Hence, you can swap in x inside and take 2 out because multiplication is commutative. Order don't matter. The answer's the same. You know, order don't matter. The answer's the same. You know what I mean? So 2 to the power x raised to the power 2 minus 1 over 2 to the power x plus 1. What is this? This is dots. What is dots? Like you said, T-Love, it's difference. This is difference. Difference means minus. 2 to the power x squared is a perfect square and 1 is a perfect square. Okay, so since this 2 to the power x squared is a perfect square and 1 is also a perfect square, we can do this. Open two brackets. Like in grade 10, you learned that difference of two squares. In grade 9, you learned that difference of two squares. You open two brackets. Then, to get 2 to the power x squared, you can say 2 to the power x times 2 to the power x. Why? When bases are the same and you are multiplying, you keep the base, you add the exponents. X plus x gives you back 2x. Make sense? So that's why 2 to the power x times 2 to the power x. It works. The factors 1, 1 and 1. And difference means you have different signs. If the constant is negative, the second term, that is a perfect